Hello, today we will learn something about the vertical relative wicking speed and try to understand how it affects the fluid transport in porous materials, especially the battery separator. So a comprehensive exploration of how liquid moves through the porous substrates or porous films like battery separators is essential for battery technology, as well as textile, medical applications, and many more. So first we need to know what is relative wicking speed. So wicking speed measures how quickly a liquid moves through a porous materials without external pressure driven primarily by the capillary forces. So this is commonly used in battery separators, which are highly porous, and the movement of liquid within the separator, which is porous, is very important. And fuel cell components, textile industry, and medical industry. So relative wicking speed allows the meaningful comparison between different materials tested under identical conditions. So what is the method to measure the vertical wicking speed? It's very simple. You need to dip a long strip which is vertically hanging into the liquid and measure the height with respect to the time. And we can do this by cutting a strip of porous materials 1 centimeter wide and 5 to 10 centimeter long. Suspension, where this strip is vertically suspended with its lower end immersed in the testing liquid such as electrolyte. We can record the height of liquid front at specific intervals in minutes or in seconds depending on its wicking speed, and calculate the wicking speed as height divided by the time. So height is in centimeter or millimeter, and time could be in seconds or minute. So mathematical expression of wicking speed is very simple. Like as I said, height of liquid divided by the time. But there are some control experiments where it should be done at specific relative humidity, temperatures, viscosity of materials. Then there is another modified equation, which is Lucas-Washburn equations. So it gives us more comprehensive analysis where we can see LT is wicking distance at a time t, gamma is the surface tension of the liquid, theta is the contact angle, r is the effective pore radius, and micro is the liquid viscosity. So this can also be used to measure the wicking speed. So how we can calculate the relative wicking speed? The formula is very simple. Wicking speed of sample A divided by wicking speed of sample B. For example, if we have materials with wicking speed 2 mm per centimeter square and another B material with 1 mm per centimeter square second, then relative wicking speed is 2 divided by 1 equal to 2. So material A wicks twice as fast as material B. So this relative wicking speed you can use to measure the relative wicking speed for your separator, or you can compare with the commercial separator. So relative wicking speed provides a dimensionless value that allows direct comparison between materials regardless of testing conditions. So there are some alternative measurement techniques. For example, gravimetric method, where we can measure the mass uptake over time as liquid absorbs into the materials, like wettability test. Or we can use the image methods and track the liquid movement using high resolution camera or scanner. It allows the real-time visualization and automated data collection. Or we can do the EIS measurements, which is also an alternative way to measure the wicking speed. So there are many applications for this technique or this test, especially in energy storage, where the battery separators are playing a key role because their movement of ion through the separator is important. And we can also use this test for the textile industry, where athletic wear with superior moisture management, that's also related to the wicking speed, and medical products where wounds dressing requires a controlled absorption rate to maintain the optimal healing environment without maceration. And we can also use in paper technology. So the key takeaways we can take from the vertical wicking speed is its fundamental property. Relative wicking speed is essential for quantifying and comparing the fluid transport in porous materials under capillary actions. Standardized testing. A vertical wicking test provides a reliable method for consistent measurement, while alternative technique offers specialized insights. Mathematical framework. Lucas-Washburn equation models capillary flow behavior, connecting the material properties to the wicking performance. Gross industry relevance is also important to understand and optimize the wicking behaviors that improves the performance in energy storage, textile, medical, and paper technology. So today we learned how to measure the vertical wicking speed. And apart from the vertical wicking speed, there is also horizontal wicking speed, for which I have made a separate video. Thank you very much.